Hello, everybody. This is Dr. Linda Koenig, and this is Counseling Research, Chapter 8. And this chapter focuses on time series designs. So let's jump right in. We're going to talk about single case research design, and you'll see that it's often, for shorthand, designated as SCRD. So single case research designs have an N or a number, sample number of 1. It can be a case study, a time series, a single subject, or an intensive design. So the goals and sort of the principles you'll see on your left, it really has no theoretical component. It is an in-depth evaluation of one individual over time, and it uses systematic repeated measures. The goal is to demonstrate a functional relationship between behavioral change and the intervention. You can see why counselors would be really interested in this. The goal is to predict, to verify, and to replicate. So the phases of a single case research design look like this. Here we have the baseline, which is where no treatment is occurring. Then we have the treatment phase here in the middle, and we are hopefully collecting our data during the treatment phase, and we have data points here. And this is hopefully showing change, and hopefully the change is improvement if we are doing therapy with an individual. And then we have the follow-up phase on this side. All right, so we can use, there's a lot of different ways to measure. We can use paper and pencil, we can use computerized data. So really what we choose depends on what questions we're trying to answer, the behaviors that we're trying to look at, and how convenient one delivery is going to be over the other type of delivery. Let's see, we want to look at both the advantages and the disadvantages of both whenever we make a choice about how we're going to deliver an assessment. So traditional assessments, they do save a lot of time. We can take a piece of paper and we can give it to our client and we can send that home with them to be completed. They can bring it back the next time, so it doesn't take session time to do that. If we're talking about a depression assessment, if we're talking about like the Conners or some type of behavioral assessment for a child, those have been normed and validated in their traditional form, but sometimes it can take time to score that, and depending on how complicated the assessment is, it could take time to interpret it. If we're talking about clients who are tracking behaviors or thought processes, those are generally a different type of assessment. They can carry a check sheet or a journal, and they can utilize those immediately. Those types of assessments can be individualized very quickly in a session or over the phone or through an email if you use some type of secured email. We use a lot of, or I use a lot of journaling and a structured journal for CBT or REBT therapy. One of the things that I am finding is that there are a lot of apps out there. So I deal with students who are in college, and a lot of students want to use some type of application on their phone. So it has the advantage of being with them all the time. They always have access to it. So the only downside to that, as far as having something be an error, is if they are entering the data incorrectly. All right, so computer-delivered assessments are less expensive. They require less effort because they don't take the counselor's time to score it and interpret it, and the results are like delivered right away. They can require the completion of all questions in order to reduce the error. Let's see. They increase standardization because every person who is using that instrument and going through that process is getting the same information from the computer. Certain programs, not all of them, but some computer software can also detect hesitation, the time between answers, if a person changes their answers, all kinds of things like this. And some clients really enjoy getting that very highly personalized feedback. All right, so models of single case research design. Time series. A time series design employs many different types of intervention models. Some of these examples are a single phase intervention, a follow-up phase or an ABA design, an ABAB, or what's called a withdrawal reversal, or ABAC, which is the combined simple phase change. All right, a multiple baseline design is in essence a series of AB designs. And we're going to replicate those. So we do it with the same person across different types of behaviors, or with the same person across different settings, or with one behavior across different people. So any of those could be considered a multi-baseline design or an AB design. It's considered an alternate to the ABAB design when it's not possible or ethical to withdraw a treatment. So one of the things that we know ethically is if we're treating somebody and that person is getting better, we ethically can't withdraw that treatment from them for the purposes of research. Okay, recording data. Unlike assessment instruments, observational data can be collected like in real time in a real setting by observation, or we can have a video recording. So observational data of a target behavior is recorded during sessions, and it can be recorded in 4 different ways. And I'm going to pause this because I'm getting a phone call. Okay, sorry about that. That was my husband wanting to know if I want him to pick up something for lunch, and I do, so that was really important. All right, so observational data can be recorded, and it can be recorded in 4 different ways: the frequency or the event, the duration, the latency, and the interval. And we're gonna look at this a little bit more in depth. All right, so the definition of target behavior is really, really critical, because if we don't know exactly what it is that we're looking for, it's really hard to identify it, especially if we're using more than one observer. So if we want accurate data collection, we have to make sure that we're defining the target behavior that we are looking for. All right, so the type of timing depends on the type of research question that we have. All right, interval recording. So there's 2 types of interval recording. There's partial interval and whole interval. In partial interval recording, whoever's doing the observation records an occurrence if the behavior happens at any time during the interval. So if we're looking at somebody for 15 minutes and then we're looking at out-of-seat behavior and that person gets out of their seat during that 15 minutes, then that is an occurrence. Non-occurrence is recorded only if the behavior does not present at all during the interval. So partial interval recording tends to overestimate the behavior, because we're going to count it as an occurrence during the entire 15 minutes if it happens one time during that period. So whole interval recording tends to underestimate the occurrence because the behavior is only recorded as occurring if the behavior presents during the entire interval. So if we're doing a 15-minute observation and the kid's out of their seat for the entire 15 minutes, we would count that as an occurrence. If they're out of their seat for 30 seconds, we don't record that at all. So you can sort of see how this would underestimate. All right, interval recording data is presented as a percentage of the occurrences of the target behavior. So here we have the little formula. We have the number of intervals of occurrence divided by the total number of intervals observed, and that's going to give us a percentage. All right, so we have momentary time sampling, and in this method, the observer only observes the target behavior during selected intervals and records occurrence or non-occurrence, which is sort of what I was talking about a while ago. The length of the observation interval and the number of intervals between observations is determined by the researcher. So, one of the advantages is the ability to record observations without taking away from observation time. Other things to consider: if we're doing observation, we want to make sure that we're doing it over several days or several weeks because we want to get a representation of the behavior that is accurate. We want to vary our times and our days for the observation. Um, I used to work in community mental health, and we would have to go do classroom observations for the Conners if we were going to diagnose a child with ADD or ADHD. And one of the things that would invariably happen is a teacher would say, yeah, you can come during my planning period or during study hall or during whatever, but it would be a particular period of time that was the same every day. And this is not going to give an accurate representation of what the child is doing. So if the teacher's planning she has students who are working on something from 9 to 10 every morning, you don't want to go 9 to 10 every morning and look at that student because their behavior from 9 to 10 a.m. obviously is going to be a little bit different than it's going to be between 2:30 and 3 o'clock. So you want to vary the days you're going, you want to vary the times of days that you're going so that you get a complete and holistic picture. All right, researchers should determine the amount of behaviors to be recorded before data collection begins and include only the essential target behaviors. You don't want to be out there recording everything that a kid does. You want to look at the behaviors that you are specifically trying to change. If it's out of seat behavior, or if it's talking out in class, whatever that is. All right, inter-observer agreement. This allows researchers to monitor the consistency with which behaviors are being measured during a study. It's referred to as inter-rater reliability and helps establish the degree that behaviors are being measured consistently. So if we have one person rating a behavior, it should be pretty consistent because the one person's going to hopefully rate everything the same way. But it's really common to have more than one rater. And when we have more than one rater, we want to establish our inter-rater reliability. In order to do that, it is also important to have each rater trained in exactly what the behavior is defined as, what constitutes an occurrence, and what does not constitute an occurrence. So once we establish this, it gives the researcher an objective comparison of how the behaviors are being recorded using the measurement instrument. All right, so in a time series design, the way that we look at the data is through a graph. So we visually inspect the graph to see what the behavior has been over time. It's a really simple tool. We can organize, store, interpret data, and we can also communicate it to other people using the graph. All right, so we interpret it through visual inspection, and there are three important types of data patterns. There's the level, there's the trend, and the variability. So level is just the average, median, or the general value of the measures. The trend is the direction of the series of data points from the beginning to the end. And if we are hoping for a behavior to decrease, then we would want to see that line going downward. If we're wanting a certain behavior to increase, then we would want to see that line going upward, or whatever direction we have set that in that would show that we're making progress in the direction we want to go. Variability is just the spread of the data points around the level and the trend. All right. So when we look at the target behavior, our definition should make it really, really easy to understand so that in the end, when we're graphing this out and we're showing a teacher or we're showing a parent, we want it to be something that anyone, any layperson is going to be able to understand. Now, this is not, I don't think, brought out very well in your book, so I added some information in here. There's another way that we can look at whether or not we're making progress when in a single case design is by looking at the effect size. So in your text on page 161, it talks a little bit about effect size, but I didn't see that it went into it a lot. And I do want you to be aware of this because you're going to see this, and at least you should have some idea of what the heck it's talking about. So this is basically just a statistical measure that says in a single case design, this effect size can be used for meta-analysis, which is when we're taking multiple research studies and combining them. So if we have 10 research studies on depression and we want to combine them to see overall what the an effect size is, we can do that. But we also can use effect size in a single case design. So this is what we're looking at. We're looking at these effect sizes, and it groups these in your text on page 161 into like the small, medium, and large effect size. And of course, the way we think about it is maybe a large effect size is better, but that's not exactly accurate. We can have a small effect size, and that can still be a very important, it can have a very important impact. All right. So here is where we're looking at beneficial effect, sort of up in here. And here was where we're looking at, we really didn't have any effect. It's just average, right? Because our percentile, would be the mean if you're looking at, if we're thinking about our bell curve, this is where our mean would be. And anything here would be to the right side of the mean. So what we don't want is we don't want to move people in this direction below them. If they started out at the mean and we're moving them this way, that's bad. We want to make sure that we have a positive effect. All right, so hopefully that gives you a little bit of an idea of a mathematical way to look at it. I want to show you this because this is really what the math is showing us. And here you see the formula. Effect size, generally, there's a couple, maybe 3 different statistics that are pretty common, but Cohen's d is what you really see all the time for effect size. So if you see d, you know that is effect size. And here's the formula. So we have mean number 1 minus mean number 2 over the standard deviation. Now, this is showing you between 2 groups. You can ignore this. What I really want you to see is this is what we're looking at. We're looking at the comparison of the means here. So if we have mean number 1 and mean number 2 in our single case design, we would be getting this from one individual, but we would take those 2 means, we would compare them, and if the effect size, we would do the math, and then we would look at the effect size between mean number 1 and mean number 2. And that would tell us what direction we're going in, and hopefully the direction that shows that we're making our intervention is progressing the person in the direction we want to go. So if we were using this in a single design, it could look something like this. So here's our ABA, our baseline treatment and our maintenance. And over here's our Cohen's d formula. And we can do this and figure out the effect size for each one of these. So here's baseline for all 3. And then here's treatment, and you can see this is a change, a different here. And then here's our maintenance, different here. All right. So in our, Oh, crap.